Well, hello, Year 12 Methods students. Today we are looking at the 2019 Exam 1, Question 8, which is parts A, B, and C. So the first one says find the rule of f, which looks like this. The second one says we've got a slightly different rule, and then we've got to find the range of the slightly different rule. So I'll jump straight in. So the first thing is to find a rule for anything. The clues that they give you is it is a polynomial of degree 4. So we have a x to the power of 4 as our highest power. So the rule is f of x equals some constant, which is the dilation factor, and it crosses here, so we'll have x plus 1. It touches here, so you'll have x squared, a repeated factor, and it crosses again at 1, so you'll have x minus 1. And to find A, you use one of the non-intercepts to figure out what A is. So don't use those or that, because that will just give you y equals 0, which doesn't tell you anything about A. So I'm going to choose this point here, which is 1 square root of 2 and 1. So when x is 1 over root 2, y equals 1. So therefore, you can replace f of x with 1 and all the x's with 1 on root 2. And then if you do a tiny bit of expansion and simplification, this will become something over root 2. So it'll be 1 plus root 2 over root 2. 1 on root 2 squared is just a half. And the last one is 1 take away root 2 over root 2. And then to get A, you need to multiply by the reciprocal or the upside down version of all this. So we're going to multiply by everything which is upside down like this, which means that A must be equal to root 2 over 1 plus root 2 times 2 over 1 times root 2 over 1 minus root 2. And then when you expand this out, you're going to get root 2 times root 2 is 2, 2 times 2 is 4, so that's in the numerator. And in the denominator, you have a difference of perfect squares. So our good friend a plus b, a minus b, which gives you a squared minus b squared. So in this case, our a is 1. So you're going to have 1 times 1, which is 1. And then you have b, which is the square root of 2. And so when you square that, it gets rid of the square root. So it becomes just regular 2. So you have 1 minus 2 in the denominator, which means you'll have 4 divided by negative 1 equaling a. So therefore, a is negative 4. So then we go back to our equation here. We know our a value now, and we can just replace it. Hello, why did you do that? So cut and paste, which gives you a negative 4 in front of here, and that's your final answer. So that's A done. Now, part B looks pretty nasty, but it's all about remembering your log rules. Oh, actually, no, not this one. So here, h is log of g. So it's helpful to have this as a picture. Can I just take a screenshot? Yes, I'll take a screenshot of this part. So it's helpful to have this picture in your mind. I'll sort of put it over here as a side reference. And so h is the log of this particular function. And then you've got another log function tacked onto it. So when you find maximal domain, there are 3 basic principles. Denominators can't equal 0. Square root whatever's in there has to be greater than or equal to 0, and logs, whatever the argument is, has to be greater than 0. So that's what you're going to use for this question. So for the logs, g of x is just what you had before. And really, I don't know why they decided to make that so complicated. They could have left it the same letter, but never mind. So this is what is your first restriction. This log, or the argument inside this log here, which color we're using, yellow, must be positive. And the other one is the other, which one are we doing this one? This argument must also be positive at the same time. So you're trying to find the overlapping area between the two domains. So we take the first one. This hard work has already been done for us because this is already graphed. So if you look at on the graph where you've got a positive y value, then it's everything using the same color, yellow, everything up here, which corresponds to x values that are between -1 and 0, but not including the ends, and between 0 and +1. So that's the first domain. For the second one, there is no graph for the second one. And so what I did was I factorized out. Now, in my haste the first time, I factorized out the wrong factor. So you should factorize x squared, which leaves you x plus 1. And then if you were to think about this numerically, let's say you don't know what this looks like. Actually, you could sketch this. This one has a sketch of touching at 0 and crossing at -1. And the shape of it is positive, so it's going to go like so. And so if you look at this one, the y values are positive for these areas here. That's the graphical approach. So you could have x between -1 and 0, but not including the endpoints, and also greater than 0. That's the graphical approach. If you didn't know how to graph it, you could just think back to first principles. X squared is always positive for all x. So if you have a positive answer, that means that you must also have a positive value for x plus 1. So x plus 1 is greater than 0, which gives you x is greater than -1. Interestingly, you lose the information that x, actually, no, you don't lose the information. The other information is because you know it's going to be positive, you know that x squared cannot be 0. So that means x cannot be 0 either. So this restriction or this domain is actually the same as this domain that you got from the graph. So then if you combine them together and see where the overlap is, let's put our x's here. Our domain for the first bit, which goes here, will be between -1, 0, and 1. And it's basically holes at that point and then connected between there. And then for the other graph, it's going to be this one. And that domain is from -1 onwards without the 0, and it keeps going. So the overlapping section between those two ends up being the holes at -1, 0, and 1, and then in between the line is joined up. So our final domain D has to be this. So just scroll down a little bit. But our domain D has to be -1 to infinity, union 0 to 1. And that's our maximal domain. Now for the for the last bit, part C, state the range of H. The easiest way of doing this is to actually use logarithm laws. So you have H is defined as these two logs together. Let's pop that here. So by log rule number 2, I think it is, you can combine them into a single log and divide the numbers together in order. So that's what we'll do here. And what else do you need to know? That will give us a very nice, easy way of sketching the graph. So h of x will equal to log to the base e of g of x divided by x cubed plus x squared. And if we write the g of x in, it's negative 4x squared. What was it? X plus 1, x minus 1. Perfect. And in the denominator, you've got x squared, x plus 1. And I took the factorized version, which is fine. Okay, so you can actually factorize out the x squareds, and you can factorize out the x plus 1s. And we've already acknowledged that x cannot be 0, which takes care of our x squared not being 0. And x plus 1 cannot be 0, which means that x can't be negative 1 either. So that's already been taken care of in our domain. So if we simplify this further, all you have is log to the base e of negative 4x minus 1. And this has a shape. Let's think this through. You have a horizontal shift of positive 1 to the right, and the negative in front here means it's reflected this way. So we still have the same asymptote, which is x equals 1. But instead of doing this, it does the opposite, which is something like that. Right, so now if we look at the range of this function, knowing that our domain is from negative 1 to 0 and 0 to positive 1, hopefully you can see that when x is 1, this corresponds with a value of negative infinity because it's all the way down here. And at 0, you want to figure out what value h of 0 is. And that gives you those endpoints there. And then you'll need to figure out what h of negative 1 is to find out what that point is. So technically, your graph is going to be not the full log. It's going to be, if I dot in the original, it's only going to be between negative 1 and positive 1 with a hole at 0. That's what actually you're going to have. Obviously, it is an asymptote, but I just sort of stopped it short. So what's h of 0 and what's h of negative 1? So let's plug it into our shortcut function, which works just as well. So h of 0 is, I got too many equal signs. Never mind, we can live with that. H of 0 is when you plug in a 0 there. So you'll have log e of negative 4 times negative 1, so log e of 4. So that means that y value is log e of 4. And the x value would be 0. And then h of negative 1 is log to the base e of negative 4, negative 1 minus 1. And that would give us log e of negative 4 times negative 2, which is positive 8. So that's negative 1 log e of positive 8. So our range is going to be from increasing order. We start here, negative infinity up to this value here, which is log e of 4, union with log e of 4 again, going up to log e of 8, which is, let's say, that number up here. And that log e of 4 is the same. Oops, wrong color. It should be this one. Okay, so that's 8C for you. So good luck with your preparations, year 12s. If you like this, like, subscribe, and share. Thank you. Have a good day.